Hello, dear all, and welcome to another interesting webinar of MD Macro Detectors. Today, we are going to talk about the CR series, which are the retroreflective area sensors. It's Giovanni Principe speaking now, product manager in MD Macro Detectors. And today, I'm going to, let's say, lead you during this interesting lecture. Interesting, I hope. I'm not alone here because a colleague of mine, Giovanni Di Lorenzo,
Good morning, hello.
Product manager in MD Microdetectors, is going to support me during this lecture. And in particular, he is going to answer to all of your questions. So if something is not so clear in my explanation, if you are curious and you want to deepen your knowledge about these products, you can write down your questions, addressing them to our Q&A profile, and Giovanni will be very happy to answer you. Right, Giovanni?
Yes, correct.
Okay, thank you very much. I think that now we are ready to start. And so let's go on. So in details, what we are going to discuss about during this lecture. First of all, we want to show you something about the technology at the basis of the way of working of these sensors. Then we are starting with a discussion about the two main series belonging to the retroreflective area sensors. First of all, the CR0 series, followed by the CR1 series. Then we can talk about some interesting applications that we already solved thanks to our sensors. And finally, as usual in our lectures, in our webinars, we have the practical part during which we want to learn with you how to adjust a sensor, how to adjust a retroreflective area sensor. And in particular, we are going to treat two modes, two teaching ways. The first one by teaching button, and the second one by the IO-Link communication. Okay, so let's start now with some hints about the technology at the basis of the of these sensors. So what is a retroreflective area sensor? But first of all, what is an area sensor? Basically, an area sensor is an array of different photo elements. So different emitters, different receivers. In this case, we have a retroreflective area sensor. So a sensor which works with the presence of a reflector installed on a wall, let's say, as it is shown in this picture. As a consequence, the retroreflective sensor has to have both the emitter and the receiver. In this case, we have a retroreflective area sensor. As a consequence, we have several emitters and several receivers. What about the advantage of having a retroreflective area sensor instead of a single retroreflective sensor? The advantage is that in this case, we can cover a higher controlled height, so a wider controlled area. So it's in the meaning of the area sensor. In particular, the CR0 products are based on 6 beams, so 6 different photo elements, 4 emitters and 3 receivers, while the CR1 products are based on 14 beams, 8 emitters and 7 receivers, with a beam pitch equal to 10 millimeters. What about the beam pitch? The beam pitch is the distance between two consecutive let's say, photo elements. And on the basis of this distance, as we are going to see later on, we can, let's say, we can compute the the minimum object size detectable thanks to this kind of products. So let's start with some common points, some common features between the CR0 and CR1 products. First of all, they have both an aluminum housing, and they can work with a maximum sensing distance equal to 4.5 meters. Then it is possible to teach them in two ways. The first one, two modes. The first one is the fine adjustment for, let's say, detecting smaller objects. The second one is the standard adjustment for bigger objects, let's say. What about the output? We have both standard output, so PNP or NPN models, with the normally closed and normally open output selectable. And we also have the IO-Link products. And in fact, during the practical part of the lecture, we are going to show you how to teach, how to adjust a sensor using the IO-Link communication. Another point that I want to stress, that I want to underline here, is the fact that the emission, in this case, the emission of the photo elements, is polarized. So this sensor is basically able to detect also transparent object or object with irregular shape. Now we can start exploring the peculiarities. So all of those features which create some distinctions about the CR0 and the CR1 products. So first of all, the main difference is based on the controlled height, the controlled area, which is equal to 70 millimeters in the case of CR0. The minimum detectable object is in this case 6 millimeters at a distance of 2 meters, and it becomes 10 millimeters at a distance of 4 meters. And what about the speed of this sensor, the switching frequency? It is equal to 400 hertz, very high. In fact, these sensors can be used besides of conveyors, which can work also at medium-high speeds. The CR1 could be, let's say, could be treated as an extension of the CR0 product, an extension in terms of height, in terms of controlled height, which is equal in this case to 149 millimeters. The minimum detectable object is equal at 8 millimeters at a distance of 2 meters, and it becomes equal to 18 millimeters at a distance of 4 meters. Also, in this case, we have a high switching frequency equal to 275 hertz. Okay, what about the LED indicators? The LED indicators are located in both in CR0 and in CR1 at the top part of the sensor, and in particular, as we have seen, for instance, for the ultrasonic sensors, we have two kinds of LEDs. The first one is the green LED, which indicates, let's say, the power supply. So it shows you if the sensor is alive or not, if it is supplied in the correct way. The red LEDs show you, let's say, the output. So they show you if the sensor is detecting something passing through the emitters and the reflector itself. the let's say the peculiarity of these LED indicators is represented by the high visibility. In fact, they are visible at 360 degrees, so everywhere in your room. Now, as I said before, we can see that we have two kinds of adjustments, and in particular, we have the standard teaching for detecting, let's say, bigger objects, and it is based on a duration of the teaching procedure. So when you push the teaching button at the top part of the sensor, a duration, I was saying, from 2 seconds to 4 seconds. The fine teaching on the other side has been studied in order to grant detection of a smaller object, and it is based on a let's say longer teaching procedure. In particular, you have to push the button for a duration going from 5 seconds to 7 seconds. Let's explore together now some interesting applications that we solved thanks to the, let's say, to the usage of these retroreflective area sensors. First of all, we can suggest the usage of the CR0 or CR1 in order to grant the so-called muting function. Muting function when we have to use, for instance, the light safety curtains. In fact, in this case, the curtains produce, as a consequence of their active output, produce a block, a stop of the machine of the plant. But this stop, let's say, should be always linked to the passage of a human, of a person, and not to the passage of a pallet, which is a desired, let's say, object. So how can I communicate to the to the light curtains the fact that a pallet or another object like a bin is passing on my conveyor? Simply by installing before these light curtains a retroreflective area sensor, as it is shown here in the picture. In this case, the sensor is detecting the fact that the pallet is passing there on the conveyor, and it allows to the light curtains to not stop, let's say, the line. But why we should install this kind of sensor and not other ones? First of all, it is very easy to install, and then they produce a secure muting activation with any targets. So do you remember when I saw that the let's say the polarized emission grants the let's say detection also of irregular, of objects with irregular shape or transparent objects. This is the case where we can apply this property. We can apply this feature. Okay, another important application in general is when we want to let's say to make a substitution of more monoray photoelectric sensors installed in parallel. In fact, in that case, we would install more sensors with more electrical connection and with more alignment problems. In this case, you have to work with just one sensor, so you can minimize the wiring installation costs, and you have no problems of mutual interference. In fact, when different and independent, let's say, sensors work together, work in parallel, they can create some interferences among them. And we have seen this concept also for the ultrasonic sensor when we talked about, for instance, the synchronization function. And I invite you to, let's say, to go online to see the record of the lecture devoted to the ultrasonic sensors in particular. Another important application is represented in this case with through the food field, when we want to detect the passage of transparent packages. In this case, we have meat packaging, and always thanks to the polarized beams, these sensors are able to, let's say, to detect the passage of this packaging and grant in this way the right supply of the food chain. Okay, let's enter now the practical part of this course, of this lecture. You can see in the video that Giovanni has already prepared, let's say, our CR0 sensor. In fact, we want to show you, first of all, how to make the teaching procedure by button at the top part of the sensor itself, with the standard teaching procedure and defined teaching procedure. And then we want to learn how to exclude some beams. And then we want to show you how to do that and more with the IO-Link communication. So we can start by the teaching button procedure. In particular, we are using in this demonstration the CR0 for, let's say, matter of space, but the same, the equal procedure can be applied for the CR1, of course. Okay, now I let the scene to my colleague Giovanni Di Lorenzo, who is going to show you how to work in order to adjust this sensor. Okay, Giovanni, you can go.
Okay, thank you, Giovanni. And today we see how to teach a standard sensor, a CR0, by the teaching buttons that you find on the top of the sensor. The first teach method that I want to show you is the standard teaching. So please check the LED on the top. I just push the button for a couple of seconds. And now we have teach the fine teach in a very easy way. Fine teach is the teach that normally you can use 80% or 90% of your application. Only in very particular cases, like detect a transparent object, like this one, is better to use different type of teaching. That is the long teaching or fine teaching. So you have to press the teaching button for 5-7 seconds. So please, also in this case, see the LED on the bottom. In this case, we have made the long teaching, and you can see that it's very easy to detect even transparent object. By the teaching button is also possible to adjust the number of beams that I want to be let active. So in normal operation, you see that we have 4 beams, four beams on the photocell. So we have 4 emitters, but using the teaching button, it's very easy to adjust the number of beams that I want to exclude. And this could be because we have a fixed part of your machine on the top, on the front. So you have to press the teaching button. And now, as you see, the LED are blinking. This means that you are entering in a setup menu. So you just pressing the teaching button, you can simply deactivate a beam. So in this case, we are operating with only 2 beams. So if you have a fixed part of your machine in the bottom part of the sensor, it's possible to install this sensor like a standard sensor. So you have just to make again the teaching, and the sensor can operate in this case with only 2 beams. So the sensor doesn't detect anything in the bottom part, but only this upper part is active. So this is a very easy way to adjust a CR0 sensor. I pass again the speech to Giovanni.
Okay, thank you, Giovanni, for your very clear explanation about the teaching procedure. So teaching procedure, so teaching by button. So what we have seen in particular, we have seen how to perform the standard teaching for detecting, let's say, as Giovanni said before, the objects in the 80 or 90% of your applications. And then the fine teaching based on a longer procedure. So you have to push the button for a longer duration, a longer time range. Then we have seen something interesting of, let's say, this kind of sensors, because the fact of having an array of different photo elements allows us also to, let's say, exclude, so deactivate some of them on the basis of our application. But now we want to, let's say, talk about the IO-Link, talk about the let's say, how to set, how to adjust your sensor by using the IODD, by using the tools of this, let's say, IO-Link communication. So now we are ready again, and I can pass again the speech to Giovanni.
Thank you, Giovanni. Now we have connected the sensor to IO-Link master, and as you can see from the LED blinking, the connection is correct. In fact, on CR sensor, when the master is correctly connected to the sensor, the signal LED is blinking to make evident that the connection is stable and reliable. Now we share the IODD, and from the IODD file, you can see on a common sheet the first information that you can have. So in the first sheet, you have information regarding the vendor, the sensor name, and 2 important information. The first is the IO-Link revision 1.1 and the bit rate, COM3. That means that the baud rate is 230.4 kilobaud. So when you use a master connected to CR0 and CR1, you have to be sure that your master is able to work in this condition. To complete the identification file, we have the identification sheet where you can find more information regarding the vendor, the serial number, and some fields that are free to fulfill by the final user to identify very special application. For example, if you have installed your sensor on a very particular machine, you can fill here all the information regarding this particular application. On process data, you have some information regarding the working condition. So the output activated or not activated, the excess gain, and so on. This information are shown by the sensor itself, and you can change this information in the parameter sheet. Parameter sheet is one of the most important sheet that you are available on IODD, because by this parameter sheet you can change all the characteristics of the sensor. The first line is regarding the teaching button. In fact, even if the sensor is connected to IO-Link Master, the teaching button is also available to the final user. So as you can see, if you teach the button, you can set the sensor without any problem. If you want to disable this adjustment, this local adjustment, you have to set the correct option on the parameter sheet, and so you can change this value to true. So in this case, even if you press the teaching button is completely disabled. So you don't have any feedback from the button. So you can restore the initial condition. On operation configuration, we have more information regarding the energy level and energy threshold of emitter and receiver. You can change this value by your hand, but normally the better thing is to accept the standard parameterization of the sensor. Only in case of very specific target to be acquired, you can change this value. In polarity, you can change from not light on to dark on, so it's very easy to pass from light on to dark on, and also to change the output logic from, for example, from NPN or PNP to NPN. This is very, very easy. Another important feature is the possibility to change the characteristic of pin 2. Sorry, the alarm was because I tried to change the second parameter before the operation was completed on the first. So you can change the configuration of pin 2, so PNP, NPN, light on, dark on, but also you can work and you can set this pin as external teach-in. So you can connect a remote teach-in button on a cabinet, for example, on electrical cabinet, and you can set the adjustment pressing the teach-in button on the cabinet. This is important because, for example, you can not have a direct access to the teaching button on the sensor, so you can remote this adjustment on your sensor. In sensor configuration lines, you have more a possibility to change the parameterization of the sensor. Working frequency is important when you have to install sensors side by side. So if you install a sensor near another, it's possible to that have mutual interference. Changing the working frequency from 1 to 2, they change the emission frequency. So in this case, they change the impossible for them to interfere. So you can work without any problem, even if you install different sensors side by side. In beam mode, you can change the number of beams that are activated. So now, as you can see, we are working on 4 beams. If we pass to 2 beams, is very easy to see that now we have only 2 beams that are active. So became very, very easy to change the number of beams that are active if you have a fixed part of your machine in the middle between sensor and reflector. So we restore the initial condition. And now you see that now the initial condition has been restored. So we are working with all 4 emitting beams. Now we are available 4 buttons for the teach-in. The first is standard teach-in. So this is the same that we have to pressing for 1-3 seconds the teach-in button. And in this case, we can have some problem to detect a transparent object. Because if the objects are very, very transparent, standard teach-in is not the correct way to teach the sensor. So we can make the teach precision, so it's a very fine teach. And in this case, as you can see, the transparent target is detected without any problem. Another possibility in case of very, very transparent target to teach the sensor is teach background and teach target. So first we teach the background, and then with the target in the middle, we make the teach of the target. So once the procedure is completed, we can see that the target is detected without any problem. So make again the standard target to restore the initial condition. In the last section, we have some information regarding the counter. In fact, you can have some event that start on timer, on temperature, on delay, and so on. And you can also change the process data. For example, if we change the process data that we see in the second sheet, now we can, if we can go back. Now, for example, we have also a temperature information. So in this case, we have that the sensor, the internal temperature of the sensor is 26 Celsius degree. The last important sheet is diagnosis, where we have a diagnosis of how the sensor is working. So in the first section, we have the general device status. So in this case, the device is okay, is working well. And in case of error and so on, you can have some other information about the problem you have. In the second section, you have some important button. I think the most important button on any electrical device is restore factory setting. So if you press this button, you restore the initial condition that you find on the sensor when is just manufactured by AMD. Then you have some possibility to change the behavior of the LED. For example, LED operation, you can disable the LED. This is important because in some application it's possible to not to want LED indication on the sensor. So in this case, even if the target and is correctly detected, you don't have any feedback from the LED. Then local indicator. In this case, if you are working on a particular sensor and you want to know what is this particular sensor, you can enable the local indicator, and the sensor became immediately evident because the LED start to blink in a very evident way. Then you have some information about the working time of the sensor. So in this case, we have that the sensor is working 24 hours from the beginning and less than 1 hour from power up. We have some other information regarding the temperature, the maximum, the minimum temperature from power up, and so on. So you can also trigger some events on this temperature. And in the last part, we have the event configuration. So you can trigger some points, some switching points, in case of some event that happens on the sensor. For example, in the first, you can trigger an event if someone is touching the push button on the sensor. If for example, if the margin is too low, the temperature is too high, and so on. Or if you can trigger an event after your sensor counts a defined number of objects. So these are more or less the main information that we can find on the IODD of CR series. And I pass again the speech to Giovanni. Thank you, Giovanni.
Thank you again, Giovanni, for your explanation about the teaching through the IO-Link communication. And in particular, with Giovanni, we have seen how to, let's say, manage the IODD file with its different sheets. Of course, during this lecture, we have seen just the main sheets, but there are other possible settings and parameters that you can use. And in particular, Giovanni shown us how to, let's say, block the teaching button in order to grant just the IO-Link teaching procedure, how to exclude different photo elements with the AND or function, and so on and so forth. Okay, now it's time to make a brief recap of the today's lecture. What we have seen. We have talked about the main characteristics of CR0 and CR1 sensors after having, let's say, introduced the technology at the basis of their working. Then we have seen together some interesting and significant applications. And finally, during the practical part of this webinar, we have seen how to adjust, how to teach a CR0 or CR1 sensor. Unfortunately, we reached the end of this lecture, but there's still more to say about the CR0 and CR1. As a consequence, I invite you to write us at info@microdetectors.com for your questions, doubts, curiosities, and also for providing us with your precious feedback about the webinars. Also, I invite you to visit our website to discover what's going on, microdetectors.com, and to subscribe to our YouTube channel and follow us on LinkedIn. And I remind you that all of our webinars are recorded, and as a consequence, you can see them again some days later in order to, let's say, to get some points that you missed. Okay, thank you for your time and your attention, and see you soon at the next webinar. Bye. Bye-bye.